Good morning, everyone.
Good morning, sir.
Good morning. All right. So let's continue with the concept. Yesterday, we were talking about block on a wedge. Let's talk about applications of pseudo force now. I've got a lift M2, M1. All right. Let's say M2 is greater than M1 or M2 greater than M1. Yeah. Okay. Now, this lift is going upwards with an acceleration of A naught. All right. Lift is going upward with an acceleration of A naught. Okay. Required to find accelerations of M1 and M2 with respect to the lift. So whenever you have an accelerated frame, it is better to go with reference. See, first we're going to choose a reference frame. Strategy is choose a reference frame, draw the FBD in that reference frame, and then write F is equal to ma. All right, write Newton's laws, Newton's equations for the system for each and every particle. So here I'll choose this as reference frame, accelerated frame, lift as my reference frame. So with respect to lift, I'll draw the FBD. FBD of M1 would be tension T, M1G downwards. Because acceleration is upward, pseudo force is downward. M1 times A naught. FBD of M2 would be tension T upwards, M2G downwards, pseudo force M2A downwards. Let the acceleration of the particles be A with respect to the lift. All right, so M1 is going upward with A, M2 obviously comes down with A. Now all that remains is to write the equations of motion. F is equal to Newton's laws, Newton's equation for these particles. So for particle 1, M1, all right, is going upward. So tension is supporting force. T minus M1 into G plus A naught is equal to M1 into A. For this particle 2, I'll have M2 into G plus A naught minus T equal to M2 into A. When I add these two equations, T gets cancelled out. I'll have acceleration as M2 into M2 minus M1 into G plus A naught by M1 plus M2. So instead of G, we have got G plus A naught. The point I want to convey here, usually we would have M2G minus M1G by M1 plus M2 if it's under gravity. But here it's accelerating reference frame with an acceleration of A naught. So instead of G, I've got G plus A naught. So what happens over here is, addition to the G field here, the gravitational field here, we have got a pseudo force field. All right. So gravitational field is G here. Sorry, acceleration to gravity is G here. So gravitational field is downward. My pseudo force field exists in this reference frame. It's a pseudo force field. It's a pseudo field. It's not a true field. It only exists because of the reference frame is accelerating. All right. So with respect to ground, there is no field as such. There is only gravitational field. But with respect to the lift, I've got additional field, which is A naught downwards. So I'll have G plus A as a net field, G effective. All right. We have talked about G effective when we talked about parabolic motion. So here also we have got G effective as G plus A. So instead of G, I've got G plus A here. That's the only difference. So with respect to the lift, it is M2G minus M2G plus A minus M1 into G plus A by M1 plus M2 by total mass. Net supporting force minus net opposing force by total mass. All right. So let us look at some situations where you need to look and say the answer, the acceleration of the particles. It's a look and say question. All right. I hope you have understood this derivation. There is a pseudo force field. That's what I want to convey. That addition to the gravitational field, we have got a pseudo force field which is added to the gravitation g, accelerated gravity g. If this is downwards, if the acceleration is downwards, my pseudo force field is upwards. So g effective will be g minus a, g minus a naught. Okay, let's look at some situations. Hmm. This is m naught, 2m naught. What is the acceleration of the particles? Can you tell me what is the acceleration under gravity? This is a, this is a. With respect to ground, the acceleration would be 2mg minus mg by 3m naught. 2m naught g minus m naught g by 3m naught. All right. So I have 2m naught, g by 3 is the acceleration.
Yes, sir.
Right. All right. Now, this is kept in a lift, which is accelerating upwards with acceleration of g by 2. So now, in addition to the g field, I've got a pseudo force field, which is g by 2 downwards. In addition to g field here, or everywhere, I've got additional g by 2 here. Opposite to the direction of acceleration of the reference frame, that's downward, that's parallel with g. So net g effective is g 3g by 2. Right? So I'll have 2m naught 3g by 2 minus m naught 3g by 2 by 3m is my acceleration A. That would be 2m naught m naught 3g by 3 g by 2. Check if the calculation is correct. Check if the manipulation, this simplification is correct. Is it g by 2 or g by 3 or what is it? Is it correct? From here to here, is it correct? All I did was 2m naught into effective g minus m naught into effective g by total mass.
Yes, sir, it is correct. G by 2.
G by 2. All right. Okay. Now let us say this is going down with g by 2. Now can you tell me what the answer is? What the acceleration of the particles with respect to the lift is? Going down with g by 2. 2m naught g effective minus m naught g effective by 3m naught. So what is g effective now when it is going downward with g by 2? Gravitation field is downward, but pseudo force field is upward. So net g effective is g by 2 minus, sorry, g minus g by 2, which is g by 2. So g effective is g by 2. Substitute g by 2, plug in g by 2 here, you'll get the answer. And these accelerations are accelerations with respect to the lift, all right, not with respect to ground. To get with respect to ground, we need to change the reference frame. Okay, tell me the answer. What is the acceleration of the particles m naught into m naught with respect to the lift?
G by 6.
G by 6, sir.
Sure.
Yes.
Yes, sir.
Okay, yeah, it's g by 6. Okay, now this is acceleration with respect to the lift. That is it's going up with the g by 6, coming down with g by 6 with respect to the lift, whereas lift is coming down with g by 2. So with respect to ground, it would be acceleration of 1 would be g by 2 minus g by 6, and acceleration of 2 would be g by 2 plus g by 6 with respect to ground, right? If I have a platform like this, on that a particle is moving with 1 meter and the platform is moving with 2 meters, so I'll have displacement of the particle as 3 meters with respect to ground, right? This is what example I can give you. Velocity of displacement of the particle with respect to the Planck plus displacement of the Planck is displacement with respect to the ground. So with respect to ground, I have 1 plus 2. If this 1 is towards left, then I'll have 2 minus 1. Similarly over here, g by 2 minus g by 6, g by 2 plus g by 6 is the acceleration with respect to ground. All right. Okay, now the question is, masses are m1 and m2 or m0 and m0 and m required to find m such that this particle 2 is at rest with respect to ground. This lift is going down with g by 2. Understand the question carefully. If you understand the question, it's 99% done. One particle is m0, the other particle is m, required to find m such that acceleration of 2 with respect to ground is 0. That is, particle 2 seems to be at rest with respect to ground. Is it possible, first of all? One is to be at rest, right? I'll make this 1. This is 2. Yeah. So 1 is to be at rest with respect to ground. That means with respect to ground, acceleration is supposed to be 0. Rest means it's in equilibrium or uniform motion. If at all I give it some velocity, it will continue to move with that velocity with respect to ground. But if this is at rest with respect to ground, its acceleration is 0 with respect to ground. That means with respect to lift, its acceleration is supposed to be g by 2 upwards. Because acceleration of the lift is g by 2 downwards, acceleration of the particle with respect to the lift is supposed to be g by 2 upwards. Do you all agree with that? Only then the net acceleration with respect to ground will be 0.
Yes.
G by 2 minus g by 2 is 0. That's what is required. That means it is supposed to be g by 2 with respect to the lift. That means this is supposed to be g by 2 with respect to the lift. So I have g by 2 is equal to m0 g effective minus mg effective by m0 plus m. What is g effective here? G by 2. So m0 into g by 2 minus m into g by 2 by m0 plus m. Let's see it's possible or not. G by 2 is here. G by 2 gets cancelled out. So I'll have m0 plus m is equal to m0 minus m. This is possible only when m is equal to 0.
Yes, sir.
Only then this will come. All right. Do you understand the question now? That means this particle is not there at all. Tension in the string is also 0 because it's coming under g by 2. This is coming under g by 2. That means it is gravitation field is g downwards. Pseudo force field is g by 2 upwards. Effective is g by 2 downwards. So it's coming under g by 2 with respect to the lift. All right. Okay. Now let's go to the next question. I've got a plank of length L. Mass over here is m naught. Mass is m naught. There's another mass m here, m naught kept here on the plank. There's no friction anywhere. There's a table here. Required to find time after which this particle will slip or fall off the plank. Before that, I want acceleration of the small block with respect to ground, acceleration of the block with respect to the plank. That's the first question I want. Answer to the first question is, that's a question which I want you to answer first. Acceleration of m with respect to ground, acceleration of m with respect to plank. These two things are required first. Then time required to fall off the plank, where length of the plank is L naught. How do we do this question? Again, I'll start with reference frame. FBD, F is equal to MA.
The masses are equal also.
Yeah, all masses are equal. M naught, M naught, and M naught. So how do we do this question? How do we approach this question? See, first of all, let us see the FBD of small mass on the plank with respect to ground. What is the FBD of small mass with respect to ground? I've got normal reaction upwards, M naught G downwards. Is there any horizontal force acting on it?
No, sir.
No. So will there be any horizontal motion?
No, sir.
So acceleration of the particle horizontal is
0.
0 with respect to ground, right? So particle will stay there itself. This will slip under the particle, but that particle will there stay there itself. All right.
Yes, sir.
Now, so that's clear. Acceleration of the particle, let's say particle A, flank P. This is particle B. All right. So particle A, block A will be remaining over there itself without motion with respect to ground. So acceleration of the particle A with respect to ground is 0. Okay, that's fine. But now, if I look at this plank and block B, what is the acceleration of the plank P and block B? If this comes down by x, plank P goes towards right by x. This will remain there itself. So this will go underneath. So this is not affecting its motion. There's no friction at all. All surfaces are smooth. So no friction ante only normal reaction is there. Reaction of N on the plank is N downwards, but that doesn't affect the horizontal motion of the plank because normal reaction is vertically aligned. Vertical on the normal reaction. Component of normal reaction horizontally is 0. So it will not affect the horizontal motion of the plank. Now, what is the acceleration of the plank? Can you tell me? Look and say acceleration of the plank and block B.
Same, sir.
Yeah. How much is it? Same. That's right. Perfect. How much is it? Okay, it is like this. M naught G minus nothing by total mass. So M naught G by 2M. G by 2 is the acceleration. It's a look and say, students. మీరు హోంవర్క్ చేయట్లేదు. You're not doing the 10-minute exercise. 10-minute exercise చేస్తే ఇది ప్రాక్టీస్లో చేశాను. ఇలాంటి క్వశ్చన్స్ చాలా ప్రాక్టీస్ చేశాము. All right. So G by 2 is the acceleration. Are you all convinced with that? Do you all agree that G by 2 is the acceleration of the block B
Yes,
and
sir.
plank M? Allow Chinna G by 2. This is M naught G minus nothing over there, 0 by total mass is 2 M naught. Is my acceleration, which is nothing but G by 2. Okay. Now acceleration of the plank is G by 2 towards right. This is G by 2 downwards. If I stand on the plank, this particle will appear to move towards left with G by 2.
Yes, sir.
So with respect to the plank, how much distance is to be covered? L naught. L naught is equal to half G by 2 into T square. So it would be 4L by G under root is my time after which the particle falls off the plank. You all understand this? Is it correct first of all?
Yes, sir.
No, there's a mistake here. There's a mistake here, students. Look at this. This is going with an acceleration of G by 2, but when I stand on this one, there's no G by 2 here. Acceleration of the plank is 0 with respect to the plank. So the acceleration of the block is G by 2 towards left. So this is covered with an acceleration of G by 2. Or I can also say FBD with respect to this plank would be normal reaction upwards, M naught G downwards, a pseudo force leftward. What is pseudo force? Mass into acceleration of the reference frame. My reference frame is going towards right with G by 2. My pseudo force will be M into G by 2 towards left. So this is my FBD of the block A. With respect to the reference frame plank, with respect to the plank, this is the FBD. So I have got a horizontal force, unbalanced horizontal force, which is resulting in an acceleration. And the acceleration, force is equal to mass into acceleration. So m into G by 2 is equal to M into G by 2, M gets cancelled out, A is equal to G by 2. So acceleration of the particle with respect to the plank from this FBD is resulting as G by 2. But I could also say from relative acceleration. If this is going towards right with A naught, that will come towards left with A naught, towards left. So if the right ki G by 2 chalte, block A will be moving towards left with G by 2 with respect to the plank. But is the block actually moving with respect to ground? No. Block is remaining there itself, but the plank is moving underneath it. It's slipping underneath the block A. All right. So here is the pseudo force applied with respect to the plank. I'm standing on the plank here. This pseudo force, unbalanced pseudo force, is what is resulting in acceleration of G by 2. Or I could as well do, I could find the acceleration of the plank. Standing on the plank, acceleration of the particle would be G by 2 towards left. Relative acceleration would be G by 2 towards left. And it will cover this length L with that relative acceleration G by 2, which is half into half AT square, L not equal to half AT square. I'll get T as root of 4L
So
by G.
how that equation came, sir?
Which one? How that? This equation?
Yes, sir.
S is equal to UT plus half AT square. U is 0, half AMO G by 2, T square. S is equal to UT plus half AT square application. Is it okay?
Yes, sir.
Acceleration G by 2. Why is it G by 2? Because my plank is going towards right with G by 2. Acceleration of the block A with respect to the plank is G by 2 towards left. Okay. Okay. Now what I do? Instead of keeping the block here, simple change in kinematic equation, students. Problem అంతా same ఉంది, but just change in kinematic equation application లో change ఉంది. If I project the particle velocity v naught here, what should be v naught? Minimum v naught for the particle to fall off the plank from the right side. What is minimum v naught for the particle to fall off the plank from this side, right side? Or what is minimum v naught for it to reach the other end of the plank? ఎలా చేస్తారు? I'll get the same acceleration as g by 2 of the plank is g by 2 itself. Acceleration of the plank is g by 2. But then if I stand on the plank now, plank మీద నిలబడితే, this block has an acceleration of g by 2 towards left, because my acceleration of the plank is towards right. Relative acceleration of the block with respect to the plank is g by 2 towards left. So particle is retarding with respect to the plank. From ground it's a little complicated. We'll analyze from ground as well, but from plank it's easy. So that's what I'm telling you. If at all you see an accelerated reference frame, you stand on the reference frame and solve the problem. It becomes simple. Only thing is you'll have to add an additional relative acceleration or a pseudo force. All right. If you're dealing with dynamics, you'll have to add a pseudo force. If you're dealing with kinematics, you just have to add a relative acceleration. Things become very simple. Look at this. If it is v naught towards right and g by 2 towards left, the particle is retarding with respect to the plank. So plank మీద నిలబడితే particle is going towards right with retardation. ఆగిపోతుంది అక్కడ వెళ్ళి, ఇక్కడ వెళ్ళి ఆగొచ్చు. But for it to stop here or fall off the plank on the right side, ఏమవ్వాలి? It should stop after a distance of L naught. So v square minus v naught square is equal to 2 into minus g by 2 into L naught. A equation is v square minus u square is 2as. Again a kinematic equation. So final velocity is to be 0 at x is equal to L naught. It's 0 అయిపోవాలి. So I'll have v naught square is equal to 2 gets cancelled out, g into L naught. So v naught is equal to 2g L naught. So that is the minimum velocity required for the particle to reach the other end of the plank. Is it okay?
Yes, sir.
I
Yes,
hope you
sir.
understand. Why is it becoming minimum velocity? I told you, whenever the question says minimum or maximum, first think why is it saying minimum or maximum? Why is the reason? What is the reason behind mentioning minimum or maximum? He said minimum velocity v naught for it to reach the other end. Why is he saying minimum velocity? దానికంటే తక్కువ ఉంటే రీచ్ కాదు, దానికంటే ఎక్కువ ఉంటే రీచ్ అయ్యి పడిపోతుంది. If it is exactly equal to that, it will go and stop exactly at this point. Okay, again it will return back, of course, because there is an acceleration of g by 2 towards left. ఇలా వెళ్ళి మళ్ళీ వచ్చేస్తుంది. So, but for it to reach the other end, its minimum velocity has to be this much. Anything less than this, it will stop before reaching the other end. ఇక్కడే ఆగిపోతుంది. ఆ ఎండ్ కి రీచ్ అయ్యే ముందే ఆగిపోతుంది. It will again come back, stop and then come back. But for it to stop at the other end, its stopping distance should be L naught. All right, so its final velocity should become 0 when it reaches L naught. Okay. All right, fine. Now let's move forward. Any question, any doubt, any visualization doubt, any ఏదైనా ఉంటే ఆపండి. All right, you ask me. Okay. Now look at this, students. I've got an inclined plane. the wedge. This wedge is going towards right with an acceleration a naught. There's a block on it, and this angle is theta, or yeah, theta. Mass of the block is m naught, or yeah, mass of the block is m, not m naught, m. Now required to find acceleration. Okay, let's study what is happening. Question comes later. Let's study what is happening. When this goes towards right with an acceleration a naught, is a frictionless floor, smooth floor, which doesn't matter. So this is going with constant acceleration a naught towards right. This block is slipping on this plan. So I have to study the motion of the block with respect to the wedge. So I stand on the wedge. I told you, whenever there is a reference frame, let us switch to the reference frame. ఇది గ్రౌండ్ నుంచి చేస్తే కొంచెం కాంప్లికేటెడ్ ఉంటుంది, ఎందుకంటే దిస్ ఇస్ కమింగ్ డౌన్ లైక్ దిస్ అండ్ దిస్ గోయింగ్ టువర్డ్స్ రైట్ లైక్ దిస్. సో రిజల్టెంట్ యాక్సలరేషన్, రిజల్టెంట్ మోషన్ విల్ బి సమ్వేర్ లైక్ దిస్, విచ్ ఇస్ కాంప్లికేటెడ్. సి, ఇది కిందకి వస్తుంది విత్ రెస్పెక్ట్ టు వెడ్జ్ అండ్ ది వెడ్జ్ ఇస్ గోయింగ్ టువర్డ్స్ రైట్. సో రిజల్టెంట్ విల్ బి సమ్వేర్ హియర్. సో ఇట్స్ రిజల్టెంట్ మోషన్ ఆఫ్ ద బ్లాక్ ఇస్ సమ్వేర్ along this line, right? But if I study this motion with respect to the wedge itself, if I stand on the wedge and study the motion, I'll have a pseudo force towards left. So let's draw the FBD. mg downwards, normal reaction perpendicular to the plane, and pseudo force ma naught towards left. Why is it towards left? Acceleration of the reference frame is towards right, pseudo force is towards left, on the particle is towards left.
Yes, sir.
Pseudo force is always opposite to the direction of the acceleration of the reference frame. All right, good. Next, this is theta. If this is theta, this is also theta. This is 90 minus theta. This is again theta. So I have along the plane, if I take the components along the plane, mg sine theta minus ma cos theta. Now there's a net force along the plane. mg sine theta minus ma naught cos theta. This is force along the plane, so I'll have max. Let's say this x-axis is along the plane, x-axis and y-axis. So that's max. So m gets cancelled out. My acceleration along the plane was g sine theta minus a naught cos theta. But what happens perpendicular to the plane? Normal reaction increases. Look at this. I've got ma sine theta plus mg cos theta. So my normal reaction is equal to m into g cos theta plus a naught sine theta. So normal reaction has increased and acceleration has reduced. Why has the acceleration reduced? If there were no acceleration on the wedge, it would slide down with g sine theta. That makes complete sense. It is 0 అయిపోతుంది. A naught is 0. It slides down with g sine theta. It slides down the plane with acceleration of g sine theta. That makes complete sense. Acceleration లేకుంటే wedge move కావట్లేదంటే, if the wedge is not moving at all, if the acceleration of the wedge is 0, I mean not moving at all అంటే acceleration of the wedge is 0, that's what I mean. Then block slides down with an acceleration of g sine theta. But when wedge is moving with an acceleration a naught, we have got a pseudo force which is opposing this mg sine theta force. So its component ma cos theta is opposing mg sine theta. So there is a possibility that this can become 0. So at what acceleration does it become 0? A naught is equal to g tan theta.
సార్ నార్మల్ అయిన ఈక్వేషన్ ఎలా రాస్తారో చెప్తారు?
E normal reaction, okay. Today, normal reaction is this way, perpendicular to this plane. mg cos theta వస్తుంది, ఒక కాంపోనెంట్ perpendicular to the plane, mg cos theta కదా, and this is ma sin theta. This is 90 minus theta. ma cos of 90 minus theta is ma sin theta. So mg cos theta plus ma sin theta are both parallel and opposite to normal reaction. And there is no motion along this line. Perpendicular to the plane, there is no motion. So net force along this should be zero. So normal should be counterbalanced by these two components. What are the two components? One is gravitational fields, gravitational force component. The other side is other component is pseudo force component. Both together add up and counterbalance N. And there is no motion along y-axis perpendicular to the plane. That's how I got this equation. N is equal to mg cos theta plus ma sin theta. Mg cos theta, component of mg perpendicular to the plane. Ma sin theta, component of ma, which is pseudo force, perpendicular to the plane. Is it okay?
Yes, sir.
All right. Now, if A is equal to g tan theta, this wedge and the block move together. That is, as a single block. There is no relative motion of the block with respect to the wedge. ఇలా మూవ్ అవుతాయి. As if there is no the combined mass laga move అవుతాయి. Because there is no relative motion between the two, I can treat them as one block. Whenever there is no relative motion between the blocks, I can treat them as one block. Right? That's what you have been doing. ఇక్కడ కూడా if this is moving with a is equal to g tan theta, అప్పుడు pseudo force component is counterbalancing the gravitational force component along the inclined plane. So mg sin theta is counterbalanced by ma cos theta. అప్పుడు a is equal to g tan theta. In that case, there is no motion along the plane as well. Perpendicular to plane align లేదు because of normal reaction. It's counterbalancing the normal gravitational force component and pseudo force component. But along the plane also there is no acceleration because there is no net force along the plane as well. అప్పుడు this mass and the wedge move together as a single block. That time I can treat block and the mass as the same block. One block లాగా treat చేయొచ్చు. Mass 1 kg, 10 kg ఉంటే I can treat them as 11 kg as one block. All right. Now let's look at a problem. This is m naught. This is m naught. This is m. Required to find m such that these two move together. Required to find m such that this block and the wedge of mass m naught and m naught move together. That means there is no relative motion of m naught small block A with respect to the wedge B. What is the mass of C? Do you all understand the question? Why is it that they'll move together on certain condition? Okay, angle I have not given, right? This angle is supposed to be 45 degrees. Now, what should be m such that A doesn't slip over the wedge B? Understand the question first. Let the question seep into your brain first. Understand the logic behind the question. What is it trying to ask, and why is the question making sense? So, shall we go ahead, or you want to think further? I'll give you a minute to think. You have to find the mass of the block C such that this block A and B, wedge B and block A move together. That means there is no slipping of A with respect to B. Any idea, students? 1 minute is done. 1 minute is done. Any idea? You want to suggest something, how to approach, or what is happening in the question? Okay, let us do it together. Let us say the acceleration of the C is A naught. All right. So acceleration of the wedge is also A naught. And I said because they're moving together, they'll move as 2m, not m and m separately, but 2m because they're moving together. I can treat this as one block like this. But then before that, let us find the condition between A naught and G such that there's no slipping. So pseudo force should counterbalance the mg sine theta component. So mg by root 2 should be equal to okay, this is not 45, this is 30 degrees. Okay, it's 30 degrees. All right. Now, so mg by 2.
By 2.
Yeah, you're right. Thank you. So mg by 2, correct? Now that should be counterbalanced by ma root 3 by 2. Right? Why is it ma root 3 by 2? ma ఇలా ఉంది, mg ఇలా ఉంది. Yeah, cos component ఉంది.
Yes, sir.
So this is theta, 30 degrees. So mg sin 30, ma cos 30. ma cos 30 is ma root 3 by 2. Now this should be equal to this one because net force on that should be 0. Only then it will be at rest with respect to the wedge. It will be at rest with respect to wedge when the net force is 0. So that is ma root 3 by 2 should be equal to mg by 2. 2 gets cancelled out, m gets cancelled out. A naught is equal to g by root 3. Alright, so my acceleration is supposed to be g by root 3. Fine, that means A naught is supposed to be g by root 3. I know how to write an acceleration of the system. It's a look and say question. Acceleration of the system A naught is equal to mg minus 2m naught minus nothing, mg minus nothing by m plus 2m naught. You all agree with this?
Sir, acceleration.
Yeah, acceleration of this is mg by m plus 2m, total mass. Supporting force minus nothing, there's no opposing force, by total mass, m plus 2m is acceleration, which is a naught g by root 3. So g gets cancelled out. I'll have m is equal to m root 3 plus 2 root 3m. M comes this side, m naught. So m is equal to m naught into 2 root 3 by 1 plus root 3 is the mass of C such that they move together. Is it okay, students?
Sir, can you explain again this?
Sir, can you repeat once again?
Yeah, I'll do it again. Look at this. I've got ఇది అర్థమైందా? Why is it ma cos theta is equal to mg sin theta ఎందుకు ఈక్వల్ చేశాను?
Yes, sir.
Because net force along the plane should be 0. Because I said particle A is at rest with respect to the wedge. That means net force on that should be 0. mg sin theta should be equal to ma cos theta. So ma cos 30 is equal to mg sin 30. M gets cancelled out. By 2 gets cancelled out. 2 gets cancelled out in the denominator. A naught is equal to g by root 3. That means the acceleration of the wedge is supposed to be g by root 3. But what is causing this acceleration? This mass, the force over here is causing this acceleration. So how will I write the acceleration of this now? acceleration is A naught is equal to supporting force is mg by total mass m plus 2m naught. Why is it 2m naught? Because both are moving together as one block. So I treat them as one block. And A naught over here is g by root 3 from here. So g gets
ఇక్కడ
cancelled out.
మనం సేమ్ యాక్సిలరేషన్ రావాలి కదా సార్ రైట్ సైడ్
ఇది
జీ
ఇది
బై రూట్ 3 ఉండాలి కదా జీ బై
ఇది
రూట్
ఓకే ఓకే అర్థమైంది సి యువర్ డౌట్ ఇస్ సి ఇది యాక్సిలరేషన్ ఎలా వస్తుంది నాకు టోటల్ ఫోర్స్ ఇప్పుడు ఒక బ్లాక్ ఇలా ఉంది దీని యాక్సిలరేషన్ ఏముంటుంది ఇది m నాట్ ఇది m నాట్ అనుకుంటే
A naught and A naught.
a naught and a naught, how much is the acceleration? Okay, here is where you are failing to do. That's okay, I'll tell you again. So for a minute, let's go back to that for a minute, then we'll come back to this problem again. Just wait for a minute, students. Chudandi, I've got a pulley, a block M1, a block M2. Let's say M1 is 2 kg, M2 is 3 kg. So what is the acceleration blocks now? I'm not asking the constant equation. I'm not asking the relation between accelerations a naught and a naught a1 is equal to a2 No, I'm asking the acceleration of the particles itself. So how will I get it? 3g minus 2g by 5. G by 5. Correct?
Yes, sir.
If this 2 kg is on a horizontal plane, now what is the acceleration of the particles? 3g minus
3g.
nothing. There's no supporting opposing force. 3g by 5.
yes sir
సో అలానే ఇప్పుడు 2m ఇక్కడ ఉంది ఇది బ్లాక్ మాస్ m ఉంది ఇది 2m నాట్ ఉంది వాట్ ఇస్ ద యాక్షన్ ఆఫ్ ద సిస్టమ్ నౌ blocks now mg minus nothing by
3m naught. Okay.
3m naught
mg by m plus 2m.
Plus 2m.
This is equal to g by root 3. అర్థమైంది కదా ఇక్కడ g by root 3 రాదు ఇది సపోర్టింగ్ ఫోర్స్ ఇది
yes sir I understand.
ఈ లుకెన్స్ when I say లుకెన్స్ you have to practice for 5 to 6 problems అప్పుడు లుకెన్స్ అయిపోతుంది అది otherwise it becomes difficult. See, for me also, if I give a break and then do it after 5 years or 6 years, మరి నాకు ఆలోచించాల్సి పడుతుంది. If I don't do at all, if I don't do physics at all, I'll have to think again. Only thing is, if I keep thinking, that will become easier for me every time. Okay, now look at the students. I've got, అర్థమైంది కదా ఇది wedge is a naught. This is 30 degrees unde. This is m naught. This is m naught. This is m. Then a naught I got as g by root 3 from this wedge condition. G by root 3 వచ్చింది. Then from this force equation I get mg minus nothing by m plus 2m naught is equal to g by root 3. ఇక్కడ నుంచి ఏమొచ్చింది నాకు alright I think I did a mistake last time. I've got m into root 3 is equal to m plus 2m naught, right? I did a mistake last time. So I've got m is equal to 2m naught by root 3 minus 1. Right? I did something wrong last time. All right. Note that. See, that's what be careful about with my calculations here. I sometimes go wrong with plus and minus. All right, not sometimes, most of the times. Sorry for that. But okay, the point is this force equation is equal to g by root 3. I mean, acceleration is equal to g by root 3. So I cross g gets cancelled out. Cross multiplying, I'll get m root 3 is equal to m plus 2m. M comes over here to LHS. M into root 3 minus 1 is equal to 2m naught. M is equal to 2m naught by root 3 minus 1. All right.
Yes, sir.
Okay. Now look at this. Let's go for one more problem. Now another situation, then we'll go for a problem. Situation is like this, students. Now this wedge is accelerating towards left. Mass is m naught, wedge is going towards left. Now what happens if this is theta? What happens with respect to the wedge? I've got a pseudo force towards right. Ma naught. Mg is downwards. Normal reaction is this way. Now what is normal reaction now? Normal reaction plus Ma sin theta is equal to mg cos theta. Do you all agree with this?
Yes, sir.
Ma sin theta. All right. This is theta. This is 90 minus theta. So Ma cos of 90 minus theta is Ma sin theta is equal to mg. Sorry, n plus this is equal to this much. So n is equal to m into g cos theta minus a naught sin theta. So again, look at this. There is a possibility for this to become 0. So normal reaction can become 0. But let us see what happens if normal reaction becomes 0. If normal reaction becomes 0, that happens at A is equal to g cot theta. When this condition is satisfied, let's see what happens. If normal reaction is 0, with respect to ground, the only force on that is mg. With respect to ground, there is no force Ma. Ma is a pseudo force that is coming into picture because of the reference frame I've chosen. Reference frame I've chosen as wedge. That is why that Ma has come into picture. Otherwise, that would not exist at all. That doesn't exist at all. It's just a pseudo force, just a mathematical term.
Sir.
But now, with respect to ground, if normal reaction is 0, what is the only force acting on this block? Mg. Right? That means it will fall vertically downwards. That means if it goes with an acceleration of g cot theta, this block comes vertically downwards. This comes here. This block comes here, exactly below it. This comes further, that will come exactly below it. So it will fall vertically downward. So that means
Sir.
as if there is no contact at all. Normal reaction 0 ante, there is no contact at all. That means this is not affecting this at all. దాని మధ్యలో కాంటాక్టే లేదు. So there is no normal reaction. That means the only force acting with respect to ground is mg, which will result in g downwards. So it will come down with g. So if at all I say, what should be the condition for this particle to come down vertically? Ante normal reaction has to be 0. In other words, normal reaction is 0, right? So what should be the acceleration such that the block should come down vertically downwards? That means A should be g cot theta. In other words, normal reaction is supposed to be 0. All right.
Sir.
Now let's see a
సార్
problem.
అది ఎట్లా వచ్చింది సార్?
Okay,
Sir,
కిందకి ఎలా
నాకు-
వస్తుందా? Vertically downward ఎలా వస్తుందా?
No, sir, ఇక్కడ మీరు
సార్ ఈ ఈక్వేషన్ సార్
Okay, ఈ ఈక్వేషన్ ఎలా వచ్చిందా?
A
Okay.
is equal to c cot theta.
ఇది ఈక్వల్ టు 0 చేశాను. It is equal to 0. So m goes to right side RHS 0, it becomes 0. So g cos theta is equal to A sin theta. Sin theta comes to LHS. G cos theta by sin theta is cot theta. So A is equal to g cot theta.
సార్
Yes, Vignesh?
అక్కడ n ప్లస్ MA కాస్ థీటా రావాలి.
చూడు, ఇది MA ఉంది కదా, MA towards right కదా,
ఎస్ సార్.
theta, ఈ యాంగిల్ theta కదా, because this
Yes,
is
sir.
theta, vertically opposite angles theta.
Adjacent and hypotenuse.
This is theta and this is theta. That's fine.
Yes, sir.
ఇది theta అంటే ఇది 90 minus theta.
Yeah, sir.
So MA cos of 90 minus theta అంటే ఏంటి? MA sin theta కదా. I will take component along the normal, perpendicular to the plane. I'm not taking component of MA along this plane. That is MA cos theta. That's fine.
Okay, sir.
I'm taking component of this MA perpendicular to the plane. That is MA cos of 90 minus theta. Cos of 90 minus theta is sin theta. Whenever you think of a component, think of cos. All right, don't remember in terms of sin or cos. Whenever you say component, think of cos of the angle between the line along which you are taking the component and the vector. So here vector MA naught, and the line along which you have to take the component is perpendicular to the plane. So MA cos of angle between these two is 90 minus theta. So cos of 90 minus theta is sin theta. That's why I got MA sin theta. So this plus this is mg cos theta. Why am I equating this? Because there's no net equal, there's equilibrium in this direction. Perpendicular plane, normal reaction is plus this one is counterbalanced by mg cos theta. Or better way of writing it is this minus this is equal to mass into acceleration, which is 0. Alright, that's a better way of writing it. This minus this is equal to 0 because there is no motion perpendicular to the inclined plane. If I stand on inclined plane, there is no motion perpendicular to the inclined plane, right? Pseudo force వచ్చిందంటే I'm standing on inclined plane. See, if I'm standing on inclined plane, perpendicular to the inclined plane, there is no motion. There is motion only along the inclined plane. All right. Now let's look at another problem. Let's say this is 60 degrees. Okay. And there's a mass here, m naught. This is m naught. And this is attached to a pulley. Here is the mass m. I have to determine m such that this mass m naught comes down vertically downwards. The small block comes down vertically downwards with respect to ground. In other words, normal reaction becomes 0. I have to find the mass m, hanging mass m, such that this mass should lose contact with this wedge. Other words, lose contact and the same thing. Normal reaction is 0 is same thing. It's coming down vertically downward with respect to ground is also same thing. Idela chestaru. Again, I'll do the same thing. Acceleration vacheka, I'll equate the acceleration to the acceleration of this block. Ante. But how to get the relation between accelerations? So I'll draw the FBD with, I'll choose a reference frame. My reference frame is going to be wedge. Because I told you there is an accelerated reference frame. Let's go for accelerated reference frame. Things become easier. So pseudo forces towards right, MA naught. Mg is towards vertically downwards. This is 60 degrees. So this is 60. This is 30. And this is 60. So I've got mg cos 60. N is equal to 0, right? So MA cos 30 should be equal to mg cos 60. So MA cos 30 is root 3 by 2 should be equal to mg cos 60, 1 by 2. 1 by 2, 1 by 2 gets cancelled out. So A naught is equal to g by root 3. So again, my acceleration should be g by root 3. Acceleration of what? Acceleration of the wedge, which is same as the mass. Now, how will I write the acceleration of these blocks? No, because m is not in touch with this one, I cannot write that along with wedge. I cannot combine these two blocks. They are not in contact with each other at all. They are not moving together. One is moving vertically downwards, one is moving horizontally leftwards. So my acceleration would be A naught is equal to supporting force mg minus nothing by m plus m naught. I will not take 2m naught now. As in previous problem, I will not take 2m naught because they are not moving together. So g by root 3 is equal to mg by m plus m naught. G gets cancelled out. So m plus m naught is equal to m root 3. So m is equal to m naught by 1 minus root 3. Is it okay, students? Have you understood what I've done?
Yes, sir.
Yes, sir.
All right. See, I have not combined these two masses because they're not moving together. I can combine them only when their relative separation is zero, relative acceleration is zero. Only then I can combine both. But here, one is coming vertically downward, this is going vertically, horizontally leftward. So they are moving independently. And normal reaction is zero. So there is no contact at all. So I cannot combine these two, they are moving independently. And this coming. And what is the acceleration of this m0 with respect to ground? M0 acceleration with respect to ground ending?
0, sir.
No, with respect to ground. కిందకు వస్తుంది కదా సో డెఫినెట్లీ యాక్సిలరేషన్ ఉండాలి కదా
Yes, sir. G.
G, right. Excuse me. Excuse me. Okay. Now, okay, let's do one more problem. There's a car in which there is a rod, and along this rod there's a bead. All right, there's a bead, and this angle is 40, all right, let's say 30 degrees. And this is going towards right with an acceleration of a0. A0 is equal to, okay, a0. Fine, I have to find the acceleration of this bead with respect to the car. How will I find? See, I need acceleration, for which I need force, for which I need FBD, for which I need reference frame. So I'll choose a reference frame as car. Car reference frame తీసుకుంటే I'll have normal reaction as one force, mg as one force. Pseudo force is towards right or left?
Left,
Left.
sir.
Sure.
Yes, sir.
Yes, sir.
Yes, pseudo force is towards left. ma0. This angle is 30 degrees. This is 30. This is 30. So I've got, so this is 60. So mg sine 30 or mg cos 60 minus ma0. So I have mg cos 60, which is mg by 2, minus ma0 root 3 by 2 is my mass into acceleration, max. Why ax? Because I'm taking this to be x-axis, this to be y-axis. Along y-axis, there is no motion because normal reaction is counterbalancing all the forces. So net force along the y-axis is 0. Normal reaction is self-adjusting. It will increase or decrease depending on the acceleration a0. But along the x-axis, I've got net force as mg sine theta minus ma cos theta is equal to mass into acceleration. All right. So m gets cancelled out. So ax is equal to g minus a0 root 3 by 2. So this is the acceleration of the bead with respect to the car along the rod. So if I ask you what should be the acceleration of car such that this bead doesn't move with respect to the car, that is bead is at rest with respect to the car, అంటే ఏం చేస్తాను ax ని జీరో చేస్తాను. All right, ax will be 0. I'll get a0 equal to g by root 3. Fine. But what if I say this bead should go up with an acceleration of g? Or g by 2 అనుకుందాం. It should go up with an acceleration of g by 2. అప్పుడు ఏం చేస్తాను? It should go up with an acceleration of g/2. ఇది మూవ్ అవ్వకుంటే it comes down with an acceleration of g/2. But what should be the acceleration of a0 such that it should move up with an acceleration of g/2? అప్పుడు ఏం చేస్తాను? What is the upward force? ma cos 30 minus downward force is mg/2 should be equal to m into g/2. Right? So 2 gets cancelled out, m gets cancelled out. So I have a is equal to 2g by root 3. Is it correct? Just check if it's correct or not. I could be wrong in this. Is it correct? Is a0 is equal to 2g by root 3?
Yes, sir.
Okay. So with this acceleration, if I move this with an acceleration of this much, this goes upward now. All right. It is defying gravity? No, it is not. Because you have got a pseudo force field here. Pseudo force field leftward undi. Gravitational field downward undi. Pseudo force field is beating gravitational field component along the rod. That's why it's going up. If both are counterbalancing each other, that will remain there. If gravitational field is beating pseudo force field, it will come down. I mean, component along the rod. All right. Now let's look at one more problem. I've got a block like this. Another block is here. This is m0. This is m0. All right. Or this could be 2m0, 1m0, anything, whatever. But the point is, this is in a car which is going towards right with an acceleration of a0. All right. Now I have to find out the accelerations of masses with respect to the car. So what will I do? With respect to car, okay, pseudo force vastundi. So this is mg as it is. But pseudo force on this will be, I mean, let's say there is a wall here. Pseudo force on this is ma0. Pseudo force on this is ma0. Here ఒక normal reaction mg. ఇక్కడ ఒక normal reaction ma0. So this normal reaction is counterbalancing ma0. This normal reaction is counterbalancing mg. So no motion along this one, no motion along this one. Motion is along vertically downward for the block, hanging block, and the block on the table is going towards right or left, depends. Now let us see what is the action of the block. How will I do it? I'll write supporting force mg minus opposing force ma0 by 2m0. This is my acceleration of blocks with respect to the car. So m0 gets cancelled out. I'll have g minus a0 by 2. Look at this, students. That means if I move this with the acceleration of exactly g, these particles will remain at rest. Acceleration 0 ఉంటుంది. If they are at rest initially, they'll remain at rest forever with respect to the car. But with respect to ground, they are moving towards right with g. Right? Because a0 is equal to g. But with respect to car, they'll remain at rest. ఇది ఇక్కడే ఉంటుంది, ఇక్కడే ఉంటుంది. ఒకవేళ దీనికి velocity v0 ఇస్తే ఇది కూడా v0 పైకి వెళ్తుంది, with constant velocity వెళ్ళిపోతుంది. v0 towards left, v0 upward. All right. v0 towards left, v0 upward. But then let us say they are initially at rest and a0 is equal to g. That means here supporting opposing force is also mg. So mg minus mg is 0. Net force is 0 on this system. Along this acceleration, mg is supporting, ma is opposing. So net force is 0. All right, students, this is a trick, shortcut trick. It's not correct physics. I cannot say mg is counterbalancing ma. They are not anti-parallel. They cannot counterbalance like that. But what I do, I presume it's horizontal, hypothetically, and I say mg ఇక్కడ act అవుతుంది, ma0 ఇక్కడ act అవుతుంది, they are counterbalancing. But it is very wrong to say that this is counterbalancing this one. ఇది ఈ డైరెక్షన్ లో ఉంది, ఇది ఈ డైరెక్షన్ లో ఉంది. All right, you try this, you think about this again. And the question is this: for what acceleration a naught will this particle move towards left? Will this accelerate towards left and this will go upward? For what acceleration a naught will this go left and this will go upward? All right, that's the question. With this, let us close, students. All right, join the next class, students. Thank you all. Have a great day. Join the next class. Next class ఉంది మీకు.